Welcome to the deep dive, where we cut through the noise and get straight to the technical details you need from the AWS ecosystem. We're looking at a really dense window this week, November 24th to the 26th, 2025, and it feels like the theme was all about pure performance engineering and deep operational control.
That's exactly right. Look, if you're a practitioner, a platform engineer, an MLOps specialist, a data architect, this is for you. We're going to be pulling out the key updates across, I'd say, three main pillars. First, AML infrastructure efficiency, then data governance on open standards, and finally, core platform resilience. We're only focusing on what directly hits your operational cost and your efficiency.
So our mission is pretty straightforward then. Pull out the details that give you performance gains, tangible cost savings, and the kind of deep control you need to operate at scale. Let's just jump right in. The biggest performance metrics are coming out of AM inference and infrastructure efficiency. So let's start with SageMaker HyperPod.
Okay, so when you're trying to scale large language models, the real bottleneck, it isn't just raw compute anymore. It's managing memory. It's managing latency, especially when you have these really long context windows.
Right.
Which is why this first update, the managed tiered KV cache and intelligent routing, is such a, well, it's a huge architectural shift.
And the numbers they're putting with this are just massive. We're talking up to a 40% latency reduction, a 25% throughput improvement, and this is the big one, 25% cost savings on inference.
Yeah.
That's not just a minor tweak. That's a fundamental change.
It is, because it solves that problem of constantly recalculating attention mechanisms every single time you reuse context, in a multi-turn conversation or just a really long prompt. Technically, what the service is doing is abstracting all that complexity away behind a two-tier caching system. You've got an L1 cache, which is your local CPU memory, super fast, right next to the compute. And then you have an L2 cache.
And that L2 is disaggregated, shared across the cluster. Why is that part so important?
Because that cluster-wide cache, and it can use Redis or its own native storage layer, that's what enables the intelligent routing. Requests get sent to the specific instances that already have the relevant computed key value pairs in their cache.
Ah, so you're not recomputing things unnecessarily.
Exactly. The computational overhead just drops dramatically. This is really AWS providing a managed service for something that MLOps teams used to have to build and manage themselves.
All those painful distributed caching layers.
Right. It lets those teams focus on model quality, not on cache coherency.
That is a huge abstraction of complexity. Okay, beyond caching, there was another big throughput optimization with EGL speculative decoding now supported in SageMaker AI.
Yes, speculative decoding is just pure efficiency. So the way it works is you have smaller, faster draft model that predicts several tokens ahead. Then the larger main model verifies them all in parallel. It's so much faster than the old way of just generating one token at a time.
And the result is what, like a 2.5x throughput improvement?
Up to 2.5x, yeah. It's about maximizing the use of that expensive GPU without sacrificing the quality of the output.
We also saw a really important abstraction for real-time apps. SageMaker AI Inference now natively supports bidirectional streaming.
This is a massive headache relief for anyone building voice agents.
Or any real-time communication system, really.
Totally. Before, you'd have to build and maintain your own custom WebSocket implementations to handle that continuous data flow. Now, SageMaker AI, it manages the underlying HTTP2 and WebSocket connections for you. The ML engineer just deals with the data stream and the model, not the messy networking stuff.
Okay, let's shift a bit to cost and resource management inside the HyperPod infrastructure itself. Two updates really stood out. First, Spot instances support on HyperPod EKS clusters.
This is critical. For driving down the cost of any large-scale, fault-tolerant AI workload. If you have training jobs or inference systems that can handle interruptions, you can now just seamlessly integrate Spot capacity. And that can get you up to a 90% cost reduction compared to on-demand.
And since HyperPod is managing the orchestrator, it handles the integration gracefully.
It does. It works with EKS and Carpenter to manage the scaling. It's very smooth.
And then to make sure we're using every bit of those expensive GPUs, we got NVIDIA Multi-Instance GPU, or MIG, support on HyperPod EKS.
Exactly. MIG is all about granularity. It lets an admin partition a single high-end GPU into multiple fully isolated resources. So you've got a bunch of smaller Gen AI tasks, maybe a few different inference endpoints, or some interactive notebooks.
They can all run on the same physical chip without stepping on each other.
Right. You maximize utilization. You don't have a single small task idling an entire A100 GPU.
The final control points here are about resilience and resource governance. They introduced managed support for custom Kubernetes labels and taints through the API.
This directly tackles a really common cost leak. You can now programmatically apply no-schedule taints to your GPU instance groups. It prevents non-AI workloads from accidentally landing on and consuming those expensive GPU resources. And HyperPod makes sure those controls persist, even through node patching and replacements.
Speaking of replacements, the new APIs, batch reboot cluster nodes and batch replace cluster nodes, they seem to round this all out.
It's about platform-level control. If a node goes down, you don't have to dig into EKS or Slurm to fix it. You just call a single API endpoint, and the HyperPod platform handles the recovery. It's much cleaner.
Okay, so the infrastructure is faster, cheaper, and more resilient. Now, what new capabilities can we build on top of all that? Let's get into segment 2, the new generative AI models, access patterns, and workflows.
Well, the headline announcement here has to be Anthropic Claude Opus 4.5 landing in Bedrock. This is setting a new benchmark, especially for enterprise use cases that need complex logic and coding.
I saw the numbers on the SWE bench, state-of-the-art for professional software engineering tasks. That coding performance is a big deal, but I think the cost implication is what makes it a game changer for businesses.
Absolutely. The technical gains are one thing, but Opus 4.5 delivers that top-tier intelligence at 1/3 the cost of the previous Opus models. When you pair state-of-the-art results with that kind of cost reduction, it makes wide enterprise adoption. Well, it makes it feasible overnight.
It also has that beta effort parameter. How does that work?
It's a fascinating control knob for developers. If you're building an app where low latency is everything, you can dial the effort down. But if you're, say, processing a complex financial report where accuracy is paramount, you can increase the effort and give the model more time to think. It gives you real-time control over that cost-performance curve.
And to support those mission-critical apps, Bedrock launched the reserved service tier. This is about guaranteed capacity, right?
Guaranteed tokens per minute, and it targets 99.5% uptime for model responsiveness. But what's really clever here is the flexibility to allocate asymmetric capacity.
Okay, unpack that. Because when you reserve capacity, you worry about getting locked into rigid usage patterns.
Not with this. Think about it. If you're doing summarization, you have a ton of input tokens, but very few output tokens. If you're generating content, it's the complete opposite. This lets you reserve your input and output token capacity separately. You only pay for the capacity you actually need in each direction. It prevents so much waste.
We're also seeing AI get pushed deeper into other core services. Amazon Lex is now using LLMs as its primary option for natural language understanding.
Which is a huge leap for conversational interfaces. Traditional NLU models really struggled with ambiguity or simple misspellings. Now, if a customer says, I need help with my flight, the LLM can figure out the intent as its status and upgrade a change, and it can correct spelling errors. It's going to drastically improve self-service rates.
For developers building more complex agents, the Model Context Protocol servers, or MCP servers, got some key updates.
Right. These are basically the knowledge retrieval frameworks for Bedrock agents. First, the AWS API MCP Server is now easier to deploy from the Marketplace. But more critically, the AWS Knowledge MCP Server now supports topic-based search.
Why is topic-based search so important for agent accuracy?
Precision. Pure precision. If your agent is trying to help a developer with some infrastructure as code, you don't want it searching every single AWS doc page. With topic-based search, the agent can search specifically within, say, the troubleshooting docs or the AWS CDK docs. It cuts down on hallucination and makes the answers much more accurate.
That precision feels like it ties directly into the new Amazon OpenSearch service Agentic Search.
It does. Agentic search basically abstracts away the complex OpenSearch query language. A user can just ask in plain English, find red cars under $30,000, and the agent uses an LLM to generate the actual DSL query. It runs the search and, importantly, gives you a summary of its reasoning. It makes complex data so much more accessible.
And for the business user, we saw embedded chat and quick research in Amazon QuickSuite.
Embedded chat is all about putting the AI where the user is. You can embed QuickSuite's conversational AI directly into a CRM or an internal portal. And Quick Research makes it even smarter by pulling in trusted third-party data from S&P Global, FactSet, and IDC. So you're blending your internal data with authoritative external market data.
Of course, all these amazing AI tools are useless without high-quality, governable data underneath. Let's pivot to segment 3. Data lakes, analytics, and data governance. This felt like a week of fundamental changes, especially around open table formats.
The big one was definitely the general availability of Apache Iceberg V3 support across the board, Glue 5.1, EMR, SageMaker. This isn't just a version bump. It brings some very specific enhancements data architects have been asking for.
Let's break those down, specifically deletion vectors and row lineage.
Deletion vectors are a massive performance win. The old pain point with Iceberg was that even a small update or delete could force these huge, expensive file rewrites and compaction jobs. Deletion vectors optimize this by just tracking the changes separately. It speeds up pipelines and drastically cuts down the cost of compaction.
So less file rewriting, more efficiency, especially for datasets that change a lot. What about row lineage?
Row lineage is a game changer for governance. It adds metadata to each record so you can track the exact history of changes with just a simple SQL query. This makes compliance reporting and auditing for sensitive data so much simpler and less resource-intensive.
Speaking of governance, probably one of the most important updates of the week was lake formation fine-grained access control now extending to write operations.
Yes, this closes a huge governance gap. Lake formation was always great at read governance, row and column filtering on selects. Now you can enforce those same permissions on DML and DDL operations, your inserts, updates, deletes right inside EMR and Glue Spark jobs. It means governance is consistent across the entire data lifecycle.
And to make compliance reporting even easier for things like the Digital Markets Act, there's now audit context for EMR and Glue Lake Formation API calls.
Right. So now your CloudTrail logs for actions like Gettable will automatically include details like the cluster ID or the job run ID. It makes it incredibly simple for security teams to correlate a specific API call with the exact Spark job that triggered it.
Finally, in the data space, we saw a big simplification for ETL pipelines with AWS Glue zero-ETL for self-managed database sources.
This just removes so much operational burden. You can now set up no-code, continuous replication from your on-prem or EC2-based Oracle, SQL Server, MySQL, and PostgreSQL databases directly into Redshift. It eliminates the need to engineer these complex, bespoke CDC pipelines. And on the other side, Redshift also rolled out federated permissions, so you can define data access controls once in IAM Identity Center, and they're enforced across all your warehouses.
Okay, data is governed, secured, and optimized. Let's move to our final segment. Operational resilience, security, and core compute. This is about platform-wide control. Starting with security hardening, Amazon S3 block public access can now be enforced at the organization level.
This is the ultimate guardrail. The threat of a misconfigured S3 bucket is always there. Now, an admin can set a single policy in AWS organizations that enforces public access rules across every account in the org. New accounts automatically get the safe defaults. It's a huge reduction in risk exposure.
And for databases, Amazon Aurora PostgreSQL introduced dynamic data masking.
Yep, via the PG column mask extension. DDM protects sensitive data, think PII, at the query layer. It can mask or tokenize data based on user roles and SQL policies when the data is queried, but it doesn't actually change the data stored on disk. It's a must-have for any compliance-heavy environment.
All right, let's pivot to operational relief. The update to AWS Compute Optimizer that recommends deleting unused NAT gateways seems small, but it's a direct cost saver.
It's pure financial engineering, and it's brilliant. NAT gateways are deceptively expensive if they're just sitting there idle. The optimizer now finds gateways with no traffic over 32 days. But, and this is the clever part, it first checks to see if that gateway is part of a route table as a critical backup resource before recommending you delete it.
That's smart, but the biggest operational relief update has to be AWS Service Quotas automatic quota management.
Oh, absolutely. How many of us have had a service fail silently because we hit some soft limit? Lambda concurrency, DynamoDB throughput. This feature just automatically and safely adjusts your service quotas based on usage. You no longer have to constantly monitor usage and manually request increases. It reduces so much administrative toil.
And finally, a really clever feature for capacity planners. Amazon EC2 interruptible capacity reservations.
This is all about maximizing your ROI investment. If you bought reserved capacity for a critical workload that doesn't run 2 till 7, that capacity just sits there, idle. Now you can make that unused capacity available as an interruptible reservation for other internal fault-tolerant workloads, like batch jobs. You save money, and your primary workload can still reclaim that capacity instantly whenever it needs it.
And just to round things out, Lambda now supports Node.js 24, which simplifies development by focusing only on async await. And for resilience, Route 53 announced accelerated recovery, giving you a 60-minute RTO for DNS changes in US East 1. That's a critical number for disaster recovery.
A very critical number for anyone building a highly available system.
So if we step back, the theme for these few days seems to be this dual approach. On one hand, massive effort to abstract away complexity, especially in AML with things like the managed KV cache. But on the other hand, providing deeper, more cost-effective organization-level controls like the X3 BPA enforcement and Bedrock reserve tiers.
I agree completely. You see this huge push for fine-grained governance lake formation on writes, Aurora DDM, and it's coupled with intense infrastructure automation. With things like programmatic HyperPod control and automatic service quotas, developers are now building these incredibly complex compliance systems using managed APIs, not manual scripts.
Which brings us to our final thought for you to chew on this week. Given this incredible investment in AI performance tooling, and now that we have the Model Context Protocol defining how agents retrieve information, what are the next manual infrastructure tasks beyond node replacement and quota management that are going to be abstracted away entirely by these new SageMaker and Bedrock MCP servers next year? And how does that continued automation fundamentally redefine the role of machine learning engineer or the DevOps specialist?
As these agentic systems get more capable and get access to broader context, that line between platform management and application development is definitely going to get a lot blurrier.
Thanks for diving deep with us. We'll catch you next time.